Hey guys, welcome to the lesson for section 2.4, finding equations of exponential functions. This is going to be part 1. I'm going to split this section into 2 parts. We're going to have part 1 is going to be focused on solving exponential equations, and part 2 is going to be focused on the actual finding of exponential equations. So let's start with, what is an exponential function? Well, from last section, we said that an exponential function is any function f of x, be written as a times b to the x, and we had 3 restrictions on those. If you watch that video, I want you to pause right now and I want you to think. If you look in your notes, it's okay. What were those 3 restrictions? Think about what they were. Welcome back. Good job pausing. First restriction was that a could not be 0. If a was 0, we have a constant function. Our next restriction was that b could not be 1. Again, we got a constant function. Our last restriction was a combination of things. It was that b had to be greater than 0. Because if b is equal to 0, we get a constant function. If b is negative, we get a weird wobbly thing. So, that's an exponential function. So I want to talk about solving an exponential equation. So what an exponential equation looks like, I'm going to go like super generic and broad. And it just simply means that we have some like a times b to the x plus some c equals some d. So we have something where our variable, our unknown that we're trying to solve for is in the exponent. We want to know how to solve that. Actually, let me go backwards. Sorry. Like this. Where the variable is in the exponent, that's going to be chapter 3. Here we're going to be solving where we have essentially a power equation where our variable, our unknown, is the base of the exponent. So we're going to talk about how to get rid of that exponent. And it's a really simple process. Okay? So there's a few ways we can do this if we have some really basic kind of understanding of exponents. So let's start with some really simple equations. If I have something like b squared equals 144. Well, what do I need? What do I want to do? What I want to do is, in the end, I want to get to a point where I have b equals. And so what I have to ask myself is, how can I get from b squared to just a b? Or in other words, b to the first power. And if you remember from chapter 2.2, or section 2.2 on rational exponents, we talked about this, doing this a little bit, right? We could either use a 1/2 exponent, or we could square root. So very simply, b is equal to the square root of 144. So b equals 12. Is that it? Is that it? It's not. That's not the only answer. And the reason it's not the only answer comes in place with this 2. It's a very special number, not just 2, but an even. And so what we get is that 12, when multiplied by itself, will equal 144. But also negative 12. Because if I take negative 12 times negative 12, the negatives cancel out. I get 12 times 12, and that equals 144. Okay, so what if I do something like, let's go a little easier numbers. Let's go say b cubed equals 125. I know I said easier numbers, and you're like, oh yeah, 3s and 4s and 125. What? This is an easy one. So what number, when multiplied by itself 3 times, equals 125? Remember, this is an example. For sure I'm going to be nice to myself, and I'm definitely going to be nice to you guys, so it's probably going to be an integer number right here. So let's just guess. Well, we know 1 cubed is 1. 2 cubed, we've talked about a couple times, and 2 times 2 is 4, times 2 is 8, so that's not big enough. 3 times 3 is 9, times 3 is 27. Okay, so we're getting bigger, but not there yet. 4, maybe it's 4. So we know these things can jump pretty quick. So 4 times 4 is 16. 16 times 4 is 64. That's like halfway there. So maybe 5. What's 5 times 5? 5 times 5 is 25. What's 5 times 25? That's 125. So b cubed equals 125 means that I get that b is equal to the cube root of 125, which tells you that b is equal to 5. Now, when we had this problem, we had said that it was 12, or actually negative 12 as well worked. And we're going to flesh these out a little more, get a little more complete with our symbolism. Would it be true that 5 and negative 5 would work here? Well, let's check. Negative 5 times negative 5 times negative 5. Well, if I just deal with these first two, the two negatives cancel each other out. Make it 5 times 5 is 25. I still have this guy. So this is a positive times a negative. That becomes a negative number. 25 times 5, that's 125. Is negative 125 the same as 125? No. And so because of that, this is our only answer. And so we can actually create a rule off of this. And I want to do one more example before we do that. I want to go with a very simple one. B squared equals negative 4. So we know that to solve this, we take the square root of negative 4. Can I take the square root of negative numbers? No, right? This would be non-real. Okay, we have some stuff here. Let's see if we can piece this together into like a process. So I'm going to erase this because I need more room, but you've got it in your notes. So if we are trying to solve b to the n equals k for b, we have 3 cases. So the equation we're trying to solve is b to the n equals k. This is what we're looking for. We have one of 3 possibilities. The first and easiest case, okay, if n is odd, then b is equal to the nth root of k. Bam. That's it, we're done. And that looks exactly like when we had b cubed equals 125. We took the third root, because cubed is 3, third root of 125, and we got 5. Now we did that mentally, but you could also use your calculator absolutely to do that. Now, our other 2 cases involve n being even. So if n is even, and, okay, now if we're solving this equation for b, that means we know what n is and we know what k is. Those are numbers in this equation. So we'd have something like b to the second equals 4, b to the second equals negative 4, b to the third equals 125, something like that. And so we are looking at our value of n. If it's even, we need to then consider our value of k. So if n is even and k is greater than or equal to 0, then b is equal to plus or minus the nth root of k. So if we think back to the example where we had b squared equals 144, well, the square root of 144 is 12. And so our b was equal to not just 12, not positive 12, but also negative 12 as well. Okay, so we have plus or minus the nth root of that k, whatever that k is. Now, what if k is 0? That's a weird one, right? Well, what number times its, let's just go with squared. So if we have b squared equals 0, what number times itself equals 0? That's right, 0. So that means the square root of 0 is 0. So that means b is equal to plus or minus 0. But 0 is a number that doesn't have a negative or a positive. It's in between. It's neither. So if we say plus or minus 0, that's still just 0. So that's what happens in that very unique case of k equaling 0. So if we ever have anything raised to a power equals 0, we know that that thing is 0, in fact. Now, our last case of the 3. If n is even and k is less than 0, then what happens? What do we say? It's really easy. If n is even and k is less than 0, then there is no real solution. There is a solution, but it's not a real solution. We'll talk more about that when we talk about quadratics in chapter 4. Okay? So if n is even and k is less than 0, such as our third example where we had b squared equals negative 4, then the answer is no real solution. These are 3 cases. When we get to an equation that looks like this, to solve it, we just need to follow one of these 3 things. We need to identify which of the 3 cases we're in, and then use that solution. It's really that simple. Now, getting to this point may take a couple extra steps, and we'll see in some examples how that may work out. So, if you are like, I'm not taking any notes in this class because everything's on a video, this is something you need to write down. This is something you need to know, and this is something you need to have with you. All right. So I want to solve some very simple problems. And I say very simple, and you may scoff at me. B squared equals 49. B to the 5th equals... where was I? Okay. I believe this is what I'm looking for. Let me double check my notes. And then let's do something a little more fun, shall we? All right. These are what I want to solve. Notice I've left more room for these because they're going to take more room. These ones here are really simple. I'm going to give myself a little more room on this one. So, what we have to do is identify which of the 3 cases we're in. The first thing we need to do is look at our exponent and then identify, is it even or odd? If it's odd, just take the root. If it's even, we have to identify whether our k value is positive or negative. Okay, so we look at this first one and we identify our exponent is even. So now I need to go, okay, well that means I'm in one of the last 2 cases. So either I have, my solution is plus or minus the, in this case, square root, or it's no real solution. So we look at our result here, our k value, and it's positive 49. So I know then that in this case, b is equal to plus or minus the square root of 49. And remember, 2, the square root, is the only root we don't need to have an index form. So if this was like 4th or something like that, we would need to have a 4 in front of that, or if it was the 5th root, we need to have a 5. But as it is with the square root, we don't need it. So now I can just grab my calculator, and I can simply use the square root button, which if you look on your calculator, if you have the same, either the 83 or 84, it's right here. So you have to hit the second button, and then that guy right there. And then we type 49 in, and lo and behold, 7. Now, that very well could and maybe should be something that you know off the top of your head. 7 squared is 49. Knowing at least, 1 through 10 squared and what those are is a pretty good idea. It's a pretty good way to kind of help get yourself started with this. If you don't, though, don't worry. You do have your calculator. I'm not going to take it away from you. So that means that b is equal to plus or minus 7. Now, you guys have a test coming up? Pretty much always after this section, you're going to have a test. On a test, if you just say 7, you will miss points. If you just say -7, you will miss points. You have to have both solutions to get full credit. What about this one? Well, start the same way. We are in a b to the n equals k situation, so we identify is n even or odd. It's odd. Easy. Then that just means b is equal to, in this case we have 5, so it's the 5th root of 243. How do I do the 5th root? Well, let's look at our calculator. There are 2 ways to do the 5th root. So the first way is a really easy, simple way. And so we have 243 is our number we want to deal with. Oop, pull this back. 243. Now, if you remember from section 2.2, rational exponents are the same as radical expressions like this, or roots. So I could actually do, for the 5th root of 243, I could just take 243 and raise it. And now, depending on which type of calculator you have, you may need to have parentheses. But I can raise it to the 1/5. We get 3. So that means that the 5th root of 243 is 3. Now, if I don't want to do that, what's another way I could do this? Another way to do this using your calculator is to first, you have to type in the root. So in this case, since we're doing the 5th root, first thing you need to type in is 5. And then you're going to use the math function here, this math menu. And if you look at your options, option number 5, in this case it just happens to be 5, it says it has a little x and then a root. And so that's what you're going to want to choose. You want to choose that option there. And so notice on my calculator, it's one of the kind of the newer ones. And so it actually moves that little 5 up into that little box. If you don't have this kind of calculator, it'll just say 5 and then it'll have that x root symbol. You have to have that 5 in front. Okay. And so then we want to take the 5th root of 243, enter, and we get 3. So those are 2 ways to use your calculator to do this. Personally, especially if it's a more complicated root like a 5th root, if it's anything other than a square root, I usually just convert it into the rational exponent because that's really easy to type. I don't have to go into menus or remember to put this first or that first. The only thing I have to do is use parentheses. So these 2 problems were pretty easy. And the reason they were pretty easy is because they were already in the form of b to the n equals x. These are not. So what do I have to do? Well, just think about any equation you've ever solved. What is your goal? Our goal is to isolate that variable. To do that, I need to get everything that's not involved in that variable to the other side of the equation. And we're going to do the same thing here. So when we're solving equations, so this is a little trick that I like to kind of remind people of. PEMDAS. It tells us how to do things, right? We do parentheses or any groupings, exponents, multiplication, division, then addition, subtraction. So if I'm evaluating a problem, I follow this order. If I'm solving an equation, if I'm undoing things, I go backwards. Think about like putting your socks and shoes on. When you put them on, you put your sock on, then you put your shoe on. When you take them off, you take off your shoe, and then you take off your sock. So to do something, you go one way. To undo it, you go the other. So first I want to undo any addition or subtraction. So this is our first thing we do. So here I have 94 times b squared plus 61 equals 5,822. So I need to get rid of the addition here. So to do that, we simply subtract 61 from both sides. We get 5,761. Now, there's no more addition subtraction, so now I move on. I undo any multiplication or division. So since we're multiplying by 94, I simply divide by 94. Looks like I need to give myself a little more room. And we get, let me copy these, John. Yep. We get 61.287, and that carries on. Now, I know what you're thinking. But you said you're going to be nice and you were going to have like good integer numbers. I'm being nice because you just use your calculator. So let me erase that one. 6b to the fourth. Okay. So now I have this equation in that b to the n equals k form. So I have b squared equals 61.287. I have to ask myself, is n even or odd? N is even. So then I have to say, okay, I'm in my last two cases, is k greater than 0? And it is. So that means my answer is b is equal to plus or minus square root of 61.287. Now, you may be like kind of concerned about these decimals, but it's totally fine. We can handle it. So if you look at my calculator, the way I solved this problem is I started with our 5,822 minus 61, and that gave us our 5,761. And then my calculator, I just hit, to get this, I just pressed divide 94. And that gave me our 61.287. So now what I want to do is I want to take the square root of that. I could absolutely just do square root, and then I could type in 61.287 just like that. Okay. But what I can also do is I can use my calculator to my benefit. And so if we look at the negative right here, above that it says ANS, just like it says right here. And that just stands for using previous answer. So to get that, you just hit second and then hit the negative sign. And so now what my calculator is going to do is it's saying, okay, you want to take the square root of that last answer you just got. So we hit enter and we get 7.829. Now, is it exactly 7.829? No. But it is approximately. So minus 7.829. Now, notice if I would have just typed in square root of 61.287 instead of using that answer, I still get the same answer, 7.829. Okay, so either way you would have gotten the same thing. It just depends on what you're comfortable with, what you like to do. All right, perfect. One problem left. Let's knock it out. So again, we just do the same thing. We see that we have an exponential here that we need to solve. So we need to isolate this b to the fourth term. So I need to first subtract 45. I get 6b to the fourth equals negative 24. Divide by 6. And I'm going to bring this up here. I end up with b to the fourth equals negative 4. Perfect. We are now at a b to the n equals k situation, so we can now identify which of our three cases we're in. Our n is even, so we're not in the first case. Our k value is negative, so that actually puts us in that third case, which, remember, what was the answer to that? That's right. No real solution. So that's all we say. So once we get to this point, we just say no real solution. And that's all, guys. That's how easy it is to solve these problems. We just have to identify which situation that we are in, whether we are in n being odd, whether we're in n even and k is positive, or whether in n even and k is negative. Okay? You may have to do a little bit of work to get there, to get to that b to the n equals k. But once you're there, it's that easy to make those solutions. Okay? Trust your calculator, be confident with yourself, and crush it. All right, you guys. I'll see you next time.